Hey Pookies, we're going for AP Statistics, Chapter 6. We're discussing random variables. So, let's start by explaining what discrete and continuous random variables are and the difference between them. So, a random variable, let's start with that, is a variable which describes the outcome of a chance process. What does that mean? So, let's say we are rolling a fair dice 3 times. We can use the random variable large X to define the number of times we roll a 5. So, probability of X denotes the probability of X for a certain value, little x. Now, once we've done this, we can plot all possible values of X along with the respective P of X. We call this a probability distribution. So, random variables always must have a numerical value. They cannot be categorical. So we're talking strictly numerical data here. A discrete random variable is a variable which has a finite list of set values. For example, the outcomes of rolling a die or tossing a coin. We usually map these with a table. So let's do an example of this real quick. Let's say the event R is rolling a 5 and the event F is failing to roll a 5. You could also call F R complement, but it's the same thing. So P of R is 1 over 6, P of F is 5 over 6. Here's our sample space. We have 4 possible values of the event X. We can either roll 0 times, we can roll 1 time, we can roll 2 times, or we can roll 3 times. This is our event, and these are all the values that it can take on. These are the probabilities for each of those respective outcomes to occur. Now, let's say we want to know the probability of rolling at least 1 5. So that means we can roll a 5 once, we can roll a 5 twice, or we can roll a 5 thrice. Either way, it has to roll a 5 at least once. So this is how that works. We add the probability of x equals 1 to the probability of x equals 2 to the probability of x equals 3, which gives us 0.422, quick number crunching. And you can also do it like this, 1 minus the probability of x equals 0, because this is the only thing we're not counting in this space, which gives us the same answer. So let's talk about mean and standard deviation of these discrete random variables. The mean of a discrete random variable probability distribution is going to be the sum of all your values times the probability of that value. And the standard deviation is this long formula right here. So let's just take a look at this using our previous probability distribution. The mean of rolling a 5 in 3 tries is 0.501. So we take none times the probability of none, take once times the probability of once, we take twice times the probability of twice, we take thrice times the probability of thrice, and that's what we get here. So we say that we expect to roll 0.5015 instead of 3 rolls of dice. And the standard deviation is, again, using this long formula here, you just add these up for all the values of x that you have. And you expect the number of 5s rolled to typically be within 0.5 of the mean. So a continuous random variable, they have an indefinite number of possible values. And, we can display these with something like a density curve. So this area under the curve is going to be the probability of something, and most normally it's gonna be like a normal curve. So a normal distribution can be used for continuous random variables. So let's talk about transforming and combining random variables. So random variables can be manipulated and translated in a number of different ways. So the statistics of these distributions, such as means and standard deviations, can also be treated like random variables. And different operations have different effects on your variables like mean and standard deviation. So let's take a look at some distributions here. When you subtract a constant c, when you subtract some constant, the mean of this distribution is going to shift by that constant. So yeah, basically, because all you're doing is, if you're adding a constant to all of the values in your data set, they're all going to shift up by the same amount, and that's going to affect all of the values, but it's not going to affect the distance between the values. So that means that only your mean is going to change. Now, so your standard deviation doesn't change at all. Now, when you're multiplying or dividing by a constant, your mean is going to change, but your standard deviation is also going to change because the space between your values is shifting. So you can mix and match these operations to have different effects on your distribution. The same thing applies for when you're adding or subtracting two means in two different distributions. And when you're adding or subtracting two standard deviations, something a little bit interesting happens. This kind of looks like the Pythagorean theorem. I don't really think it has anything to do with the Pythagorean theorem, but basically, how variance works is because variance is the square of standard deviation. Variance is equal to the variance of x plus y is equal to variance x plus variance y, and the standard deviation is just going to be that whole thing under the square root. The standard deviation is the square of variance. So the last thing we're going to discuss here is two specific probability distributions, which are quite common. They are binomial and geometric distributions. These two distributions have similar but slightly varying properties. So before you can start doing calculations on a binomial distribution, there are some conditions that need to be met, and the way my teacher taught me to do it was to use the acronym BINS. So B means binary, which means there are only two possible outcomes that you're looking at, which are most usually labeled success and failure. I means independent, which means that your previous trials won't affect the outcome of your future trials. The N means number of trials, which means there must be a set number of trials that you're looking at, specific, like 20 trials, 30 trials, whatever. Either way, you stop after a certain number of tries, and you stop after a fixed number of tries. And S means success probability is constant, so the probability of success must not change. It is denoted P. So this is the formula that we use to calculate the probability of any number of successes. And the probability of your event X is always going to take on some integer value. So you can't have half of a trial, so you can't have half of a failure or success. So here's the probability that X is equal to the number of successes. This is N choose X, which is a long and complicated formula that we don't really need to know. This is the probability of success to the power of number of successes, and this is the probability of failure to the power of number of failures. So this looks like a really complicated formula, but it's actually not that bad. So just to give an example here, to show you this is not as actually as bad as it looks, let's say our event X here is hitting a kid with an apple. I have apples and I'm throwing them at kids. So let's say I'm going to try, or I have 15 apples. That's my number of tries. I have 15 tries to hit a kid. And the probability that I hit a kid is 70%. I have pretty good aim. So the probability that I hit a kid is 0.7. What we're going to do is the probability of X. Let's say we want to find the probability that I hit 12 kids. So the probability that I hit 12 kids is going to be equal to 15 choose 12 times 0.7 to the 12th power times 0.3 to the 3rd power. That's all this is. That's the entire formula here. This is n choose x, this is p to the power of x, and this is 1 minus p to the power of n minus x. 15 choose 12 times 0.7 to the 12th times 0.3 to the 3rd. And if we calculate this out, 0.17. There's about a 17% chance that I'm going to hit 12 out of 15 kids with apples, given that I have about a 70% success rate. So let's talk about the mean and standard deviations for the binomial distribution. The mean of a binomial probability distribution is really easy. It's n times p. The average number of kids that I'm going to hit out of 15 tries is 10.5. The standard deviation of a binomial probability distribution is equal to the square root of the number of trials multiplied by the probability of success and the probability of failure, which is what that looks like. This is equal to, we can just take this, 10.5, because you can see this here is the same as this here. The number of kids that I'm going to hit is on average 1.775 within the mean. So the geometric distribution is kind of like a binomial distribution, except it's easier. What this means is that you keep trying until you get an outcome different than what you were getting before. So let's say I keep throwing apples at kids until I hit one. So the conditions for this are essentially bins without the n, because you don't have a fixed number of trials. So the probability of getting a success on the xth trial can be calculated using the following formula. 1 minus p to the power of x minus 1 times p. Let's say I hit my 7th kid. You can see this really isn't that hard. Just visualize this. I fail, I fail, I fail, I fail, I fail, I fail. And on my 7th try, I succeed. I hit a kid. So that's how that works. So the mean and standard deviation of a geometric distribution, the mean is just 1 over p. On average, I'm going to hit a kid after 1.43 tries. And this is the standard deviation of that. I'm usually going to hit my first kid within 0.782 of the mean. Now, some of these calculations will be a bit of a hassle to do by hand. You won't want to be writing n choose x all the time. So you can use the calculator to give you a bit of a hand. I will be using the TI-84 plus CE. So if you go to second and distribution, you can find the correct function to do binomial PDF or geometric PDF respectively. PDF just means probability distribution function, so you can find the probability of a specific event occurring just by filling out the parameters and hitting enter. You might need to find the values of some of the following, so these can be found using a number of calculator tricks. So what you're going to want to know is that x and n are always integers. This is going to help you to figure out some of these. So binomial CDF, which means cumulative distribution function of these parameters n, p, and x, will give you the probability of up to a specific number of successes. So that's essentially what this is equal to. So if you want at least a certain number of successes, which is this, you're going to want to do 1 minus this, and then this, and x minus 1. If you want greater than a certain number of successes, you're just going to want to do 1 minus binomial CDF of these parameters as standard. You don't have to subtract 1 from x. And if you want to do less than number of successes, which is going to be this, it's going to be a binomial CDF of n, p, and x minus 1. Now these rules are going to be pretty difficult to remember, so what I suggest is that you add the binomial PDFs. Remember that binomial and geometric trials are always integer based. You can never have half of a trial. As such, things like this and this are going to be equal. Same with this and this. So that's essentially probability distributions in a nutshell. Don't be afraid to ask if you have any questions, comments, or concerns, and I will see you guys later.